Cool. I'm going to take that as we're live. Cool. Yeah. Thanks for being here, everyone. We're here today to talk about switching our mindset from imperative to declarative UI when it comes to building our applications. My name's Birch, and I'm here with my friend Prateek. And yeah, we're going to both present this to you this morning. So just to set some expectations, in this talk, we're going to be taking a high-level overview of declarative UI, learning exactly what it is and the ways in which we'll need to take a different approach to thinking about such frameworks. But before we get started, we'd love to take a look at how things currently are and put things into a bit of perspective.
Awesome. So in the 10 years since Android has existed, smartphones have evolved radically in terms of their capabilities. These capabilities have unlocked a lot of advanced and sophisticated use cases that we could not have imagined just a few years ago. And with these capabilities, apps can do a lot more today, and users' expectations of their apps have also increased. So if we look at the timeline of developer-centric announcements over the past decade since 1.0 was announced, we've had quite a few significant changes that have influenced the way in which we build our apps, Kotlin being one of the major ones. But if you look closely, we've not really had major framework or tooling-related changes that affect how we build the front end of our applications. So libraries like data binding, recycler view, and constraint layout have assisted in the UI development process, but they were more like improvements that tried patching the rough edges of the current UI toolkit. So if we quickly take a look at the conventional way in which we would build a screen, not much has really changed on Android. We start by creating a fragment layout that houses our recycler view, and then we create a separate list item definition for our list, and then we finally wire everything together in our fragment using the adapter. And I sort of overly simplified the process by just using the file names. But if you look at the amount of code one has to write to scaffold something rather straightforward, which in this case is just the fragment layout, it's clear that we're writing a lot of code. And it turns out that this is not a platform-specific problem. Writing UI code has conventionally been very explicit and ceremonial. In this case, all I wanted to do was show a hello world text on the screen, and I needed about 20 lines to achieve it. So even if I eliminate the ceremonial pieces here and look at just the relevant bits, this is still a lot of explicit step-by-step drawing instruction. It gets worse on iOS, and while it's not common for us to work directly with the storyboard's XML file, you might come across something like this when reviewing a PR. So if you ever need to reference the backing code, you'll see how difficult it is to understand. And as your layouts get more complex, this file gets even more unmanageable. So in this obscure mess, we just had 2 lines that were relevant to our intent. Writing UI code has also been very vaguely opinionated. This screen can be built as a fragment using usual view groups and widgets. But if you want to avoid the lifecycle hell, you can also build this out as a custom view entirely. So essentially, there's no clear indication around best practices. And if you want to come back to the screen and change the code structure, it will essentially turn into a rewrite. It's the same on iOS. You can either build the screen using storyboards with the interface builder or build it in code using Swift. Whichever way you choose, it's difficult, if not entirely impossible, to come back later and switch the implementation out. Writing UI is also separated by language. On Android, you write your layouts in XML, and any backing styles and theming go into a separate styles.xml file. This layout is then inflated by your activity or fragment, which is written in Kotlin, and then your UI is hydrated with data that comes from your view model or presentation layer, which is also in Kotlin. So there's a lot of context switch involved. And if you've been doing Android for a while, you might have been conditioned into getting used to it. But for people who are just starting out, this is very confusing. On iOS, you build your layout using Interface Builder, which generates an XML representation in storyboards. And the views are then referenced in your view controllers as IB outlets. If there's any actual architecture in place, then these views will be hydrated with data that come from your view model. The web is no different, and this is one of the platforms that has been doing this for a while. You write your layouts in HTML, you style them in CSS, and then you flesh it out with actual data and logic via JavaScript. So every modern application uses some sort of architecture to reduce coupling, to make things more testable, and to isolate related concerns into their own modules. But these architectures have only helped us organize our business layer. When it comes to the presentation, we're not doing anything drastically different from what we used to 5 to 6 years ago. And this is where declarative UI frameworks come into picture. But before going into declarative UI frameworks, I think it would be beneficial to understand what declarative programming is all about. So declarative programming is a programming paradigm, which is a style of building the structure and elements of your program that expresses the logic without describing its control flow. And the stress here is on building structures by describing their flow and logic and letting the compiler figure everything else out on its own. So declarative UI frameworks draw on that same idea by letting you describe your UI without the precise steps and letting the framework figure out the exact steps to build it out. The three popular native declarative UI frameworks in use today are SwiftUI, React, and Jetpack Compose, which is in alpha right now, but it should hit stability sometime next year. So let's take a look at what it's like to build UI using declarative UI frameworks. A core idea that these frameworks are built upon is breaking the screen down into smaller reusable components. And this concept was pioneered by React. So the screen can be considered as a composition of the email list component and the bottom app bar that also serves as a scaffold for this email list. The email list is composed using an email card component, which is in turn built using 3 text components and an image component. These UI components are described as a composition of fundamental building blocks instead of explicit drawing steps. So in this case, we have a vertical list of 3 text tables and a horizontal container that houses the list and the image. A regular model is then used to hydrate these components with actual data. And you can already see how easy this is on the eye. So if you look at what their implementation looks like in SwiftUI and Compose, in both these implementations, we have a row or an H stack that lays out items horizontally. We then have a V stack or a column implementation that will lay out the 3 text items vertically. And then across both platforms, the fundamental elements are laid out in somewhat of a similar fashion. So there are a few things worth appreciating here. First, this is a lot easier to read and reason about. And second, compared to the conventional approach, this is a lot less code we are writing. And that's even after I account for the code for building the actual list. And this is in stark contrast from a conventional recycle view implementation on Android or a table view implementation on iOS. We are also now focused on describing the UI instead of the explicit steps, which means you get to iterate faster on your thoughts without getting
So let's take a current modern approach to how we might build Android apps. We have our layout logic, as well as the view model, which controls the state of that screen, along with a layout file which depicts how that screen should look. The class which the controls logic of the screen will trigger actions in the view model in order to control its state. And then the view model will pass back its state to trigger certain aspects of that screen. And this is fine. And the separation here is great. We have a single source of truth in our view model, and the activity is observing that. When this state changes, the layout will change based on this. The problem here is that we are now coupled to a completely different concern, and often a different language, which in the case of Android can be XML. So here, we not only need to verify that these dependencies are satisfied by the layout statically, but that they will be satisfied for the whole life of the program. Here we are telling our UI what it should be doing. We are not actually defining the UI of our app. And this is where the issue is. Rather than just defining the UI at the point of the observation in our activity, we take the result and then tell something else what it should be doing, thus increasing the concerns that are being communicated with. This also increases the scope of change. So in order to add a feature or maintain something, we need to touch multiple points within that scope. And in Android, we don't always have a guarantee that a reference we are accessing still exists. So finding a view by ID could end up in a null result. And whilst we have newer things such as the view binding library to help with this view nullability, it is still the case that this view could not exist in our layout. And because something can be null, it can be easy to introduce bugs into any changes that we are making. Some UI frameworks have also been around for years, for a long time. And not that time is essentially always a problem, but as Prateek pointed out, when initially built, these are not always built with today's constraints in mind, and things have changed a lot. We have things on Android such as the support library, and other platforms have similar things in place to aid these issues. But whilst we can eliminate that XML and have everything as custom views in our applications, we still only have that. We still have that same issue in place as we're still dealing with these legacy frameworks, even if our components aren't built in layout code, so to speak. We also have complexity, which comes to mind. So within imperative frameworks, we see a great level of this, whether it's managing view state and also how those views are constructed within our layout. So let's take a quick example of some UI. Here we have some cards from a language learning app, and these cards can represent several different states. In this app, we have different lessons, and the user can have a score for those lessons. So we want to show a card that represents that lesson and the user's score. The user might want to favorite that lesson, so they can favorite it, which will add a star to the left-hand side of the UI. Or in some cases, there may be an error updating the user's score or fetching some information from the server. So in those cases, we're going to show that warning symbol. If we were to have this in an imperative style code to control this, we could end up with something like this. We can see here that we are manually controlling the visibilities of our views. So this layout is going to be statically defined in our XML layout. And then what we need to do is we need to check the properties of that lesson and then show or hide the views accordingly. As we can see, this results in quite a lot of code. And if you make a change here, it could be really easy to introduce something by accident, especially if your code isn't covered by tests. If we switch this to a declarative style, our code not only becomes a lot more concise, but it becomes a lot more clear in what it's doing, and it's telling the UI what should happen. We have no kind of view modifications. We're not saying, oh, this should be shown, this should be hidden, and we're not changing any properties. We're essentially just adding the view components based on that lesson object. So if a lesson represents an error, that is what our UI is going to represent without having to worry about anything else. And the key here is that we are defining what our UI is rather than manipulating it. This brings in a lot more predictability when it comes to the state of our UI and reducing the chance of any bugs that may occur. And it's not just the APIs from declarative UIs that are nicer to work with, but the practices which they bring can actually help us to write better code and build better applications for our users. So from the examples we just saw, we get a collection of improvements from declarative UI. So our apps can become more stable, and with the reduced changes and that single source of truth, we can become more confident that our UI represents what we intend to display. And with this, things also become way more maintainable, as if we are changing some part of code, we can be more confident that we are not interfering with some other piece. This in turn makes things more testable because things are more predictable. Now, a big concept for declarative UIs is state and the way in which it is organized. So we had an internal joke that saying declarative UIs over and over again is going to result in some mistakes. So apologize if we mess that up. But so what is state? We've talked a lot about state and it's come up a lot, but what is it? All applications display some form of state. A few examples of state in Android applications could be maybe a switch that's been toggled on, a snack bar that is showed under some condition that shows some form of message, or even an item that is shown within a list of content, such as a news article, or those lesson items that we just saw. When it comes to state in declarative UI, we begin to move away from unstructured state. This is when we use view properties to manually change how a view is presented, as we previously saw. With declarative UI, we begin to see the concept of unidirectional data flow. This is essentially one-way data flow, which means the data has one and only one way to be transferred to other parts of the application, or view components, so to speak. In this concept, we have our app state, which is passed to the UI, and then the UI is updated to reflect that state. With the removal of unstructured state and the need to manually assign individual view properties, we can utilize unidirectional data flow to have our UI built and rebuilt whenever state changes. This works perfectly as we can ensure that all of our UI components are referencing the same piece of state. This causes them to always be up to date, and that way we don't need to individually worry about modifying UI components outside of the global screen state. Now, this is our kind of a high-level view, but what does this mean for our component trees? In declarative UI, such as React or Compose, the aim is to pass our state from the top downwards. So our parent component will receive or hold some form of state, and then pass that data down through to the children as required. If any of those children or components need to trigger events, those are then passed up through the components, and that way the parent component can then handle the state and the whole cycle happens again. So the overall aim, an important concept to remember, is that the aim is to pass state down and then flow the events up. With these, we can already start to see in the tie with unidirectional data flow. But when it comes to the concept of this state, how does this actually map to the UI of our app? Within declarative UIs, our UI is represented by the functions that are used to render it. So the UI of our screen, or even its components, are represented by these functions, and each of these functions take state that are represented by their parameters. So when the state of our app changes, this triggers a redraw of the user interface. There is no imperative changing of the UI itself, such as setting text or visibility. You change the state, and the UI rebuilds from scratch using the functions of the components. So essentially, those functions are called, and the state will be passed into those functions. And if that state has changed from above, those functions will have the updated state, which they can then reflect when rebuilding the UI. So let's take this screen as an example. We have an area of the screen which can consist of a list containing articles, which the user can choose to read. When it comes to the state of the screen, we need to think about the different scenarios that can occur or that we can be in. So in terms of these states, we could be displaying a list of items, or there might not even be any items to display, as it might have come back empty. The screen could currently be loading, or there could have been an error in actually loading the content to display. So there we have four different states, and those are kind of states that we need to represent in our UI. With this in mind, we can construct our state based on these concepts. Our state object will consist of the items, whether or not the screen is currently loading, or whether or not there has been an error. So in the case of our screen is loading, that Boolean flag will be true, so our UI will reflect that. We could also have a list of content, and this would also be represented in our UI. If there are no items to display, the empty content view will be rendered on screen. And finally, if something's gone wrong whilst fetching the data, the error state will be shown. So how does this work? Remember on the previous slides, we talked about how we are declaring what the UI is rather than modifying these individual properties. So in this case, we are creating the UI components based on this state. We are not modifying any properties there or changing anything else related to any components. We literally declare what the UI is based on the current state. So if this list is empty, we add the empty view. If the list is not empty, we show the list view and so on. So you can break down any of your screens into kind of these state objects and then build your UI based on that. This would look something like this in terms of our declarative code, and we'd have our content function, which takes a state, and then the state properties would be checked to show the corresponding views. So if our state objects represent that it's loading, we're just going to render the progress content view. If successful, we want to show the list of items, and in this case, the UI will be re-rendered and the list would be shown. Now, because we haven't said that a progress should be shown here, it would automatically be replaced from this previous state of the UI. We don't need to worry about, oh, we should set this visibility to gone or invisible or so on. We just only care what is being declared here and in the now. So we covered the overall high-level state of the screen, but what happens a bit more into the component trees? So if, for example, the list itself is made up of child components. In terms of a tree, this would look like so. We have the parent node, which is the list itself, and then each of that list's children is represented by a child node. As well as the high-level component state management, we might also be curious about what happens lower down in these chains. In the case of React, for example, each item in this list is given a key, which allows the identification of these items, which are going to be changed or removed, allowing these children to be changed rather than re-rendered as a whole list. And Prateek will touch more into those internals in a bit. The important thing to note is that whenever some app components need to update the state, it can do so using any kind of update function. And those state changes only update the required components. So, for example, it might be the case that one of the titles in our news item changes. In this case, we'll only want to update that child. We don't want to re-render the whole list. So here, a node within that list item has been changed. In this case, the compiler will detect this, know that that child with that specific ID or position has changed, and only update that child component. And it could also be the case that we add another item to the list of news articles. Again, we don't want to re-render that whole list. The child node will be added to our parent node, and again, the compiler would identify this and render the update based on that. And finally, an item could be removed. Similarly, as the previous examples, the compiler would know that specific item has been removed and re-render only that part of the UI to affect the change.
So as Joe mentioned earlier, we can think of UIs as trees, with the container as the parent and other views as the node of the trees. So if we look at how we update the trees in the conventional way, we have a user input which transforms and emits some data. This is then consumed by the UI. And then through some tree traversal magic, a specific node is updated. When compared to the way in which we do this in declarative UI frameworks, there's a user input which transforms the backing state of the app. And this backing state could be a state val in Swift, a React prop, or a composable function for app. This transformation then commits a new tree entirely. And there are a few benefits to this approach. One, it's easier to read and debug, because now when debugging these functions, you will always start fresh instead of assuming a previous state. Also, one implementation will cover all your cases, which makes this more concise and easy to understand. But when it comes to trade-offs, in this case, it seems inefficient, and rightfully so, because you're recreating the entire UI instead of partially updating it. And that contradicts our current understanding of flowing and performance. But if you look deeper, these are misconceptions rather than trade-offs. So imagine we lived in a world with infinite resources and no compute constraints. In such a world, recreating your UI from scratch won't be that bad an idea. In fact, in that case, tree mutations will be like a lot of work in comparison. Our code bases will then just look like a bunch of functions that massage and transform data that your UI consumes. This means that our projects will be able to shave off complexity by an order of magnitude. And the benefits in this case would be that you write less complex code and everything is super easy to understand and follow. But in reality, that's not the case. And while we don't have infinite resources, we can afford some trade-offs though. Declarative UI frameworks trade off performance slightly to offer the great developer experience and all the other advantages that Joe mentioned earlier, like a proper state management model and unidirectional data flow. And the reason why these frameworks can do so is because they are optimized at the compiler level. So on surface, it seems like we are recreating the UI from scratch, but internally the tree is diffed and partially updated. And this was pioneered by React with its virtual DOM model, where it compares the content of the virtual DOM with the actual one and it only updates the nodes that we change. So we no longer need to overwork ourselves with worries about overdraw and performance, and we have these nice abstractions to work with, while the framework will do all the heavy lifting for us.
Cool. So a big question probably on a lot of people's minds is, how can we get our apps ready? Jetpack Compose is still some time away until it's going to be ready for production, although I've already seen some people talking about using it in production apps. So, but we can still start thinking about this stuff now in preparation for when we all feel comfortable putting that out into production. Whilst we're not going to go and suddenly refactor our whole app to Jetpack Compose, as tempting as it might be, it can help to start thinking about the work we're doing leading up to then and how it can complement the approaches that will be used for declarative UI. And as a note, this isn't about doing things for the sake of it. These frameworks will not only help us to create more stable apps, but also increase developer productivity and also help with things like hiring, for example. Like, who wouldn't want to work at a company where everyone is using Jetpack Compose already? So a big thing here is really having a declarative mindset. Some of the things we've talked about here and things you may read elsewhere, a lot of these things are not actually specific to declarative UI and are things you can already do now in your work and the things that you're building. So to begin with, where does the state in your app currently live in the features and components that you're building? Start thinking about this when you're next building things or when you're making changes or fixing bugs. We mentioned previously about passing state down and flowing events up. The more of that we can achieve, even bit by bit and slowly, the more we will have in place ready to support these frameworks when they come in place. This naturally leads us back to unidirectional data flow. This is something we are already doing at Buffer in our Android app and have been doing for some time now. And I know a lot of other apps from people I've spoken to in the community are doing the same thing for some time. As noted in the examples of this talk, having that single source of truth that represents the state of your screen, that is perfect for declarative UI and will really help with your transition to Jetpack Compose, for example. You have the single source of truth which represent the current state of your UI, regardless of whether you have declarative UI or not. And on that, because the Android view model and Jetpack Compose has great support for working together, you can utilize the view model from those previous examples that we saw. If you're using the view model currently or thinking about switching, using it for your single source of truth, offloading your state there and ensuring that it is being used to handle any of the logic around your app is a great way to sort of set you up for success. The more that you can do to have this in place, the smoother your transition will be when it comes to Jetpack Compose. And for example, in our apps, we have our view models on some screens, but some of the logic is still all over the place, and we're slowly moving things into the view models for those legacy classes. And when we come to using Jetpack Compose, that will help us to transition in a more smoother fashion. And with this unidirectional data flow and all those things mentioned above, this gives you the opportunity to decouple your UI from the logic of your app if you're not doing so already. If you can do the work now to ensure that your UI components are free of logic around both business and state and be as lightweight as they can be, when it comes to taking on frameworks such as Jetpack Compose, your task will be much smoother as it will become more of a case of just switching your UI components out rather than having to refactor state at the same time. Cool. With that said, that's everything we wanted to talk about. So I guess that's all, folks. I'm not sure how questions are working here, but I think we've got a few minutes for Q&A if so, or feel free to reach us out on Twitter if you prefer to ask questions there, and I'll be happy to. Oh, here we go. That's how it's working. Cool. So there's a couple of questions here. How does Compose handle UI differences depending on configuration? For example, different layout in portrait, landscape mode. Good question. As far as I haven't tried that yet, to be honest. I know that if we're talking about configuration differences, I know when it comes to things like theming and stuff, and there are ways you can detect stuff. So I guess that would be a part of the state, maybe. I'm not sure if Prateek has any thoughts there, but I imagine maybe I know some apps have had like a dark theme state or a theme state, for example, and then you'd switch that based on whether it's a light theme or dark theme. I know that's how people do it in React. And then when that state is switched, then the theme changes accordingly. So maybe you could do something similar there, like detecting there's ways to detect if we're using portrait or landscape on a phone. So you could switch that state flag based on that, and then the UI could be redrawn. What does Compose look like behind the scenes? Do components have generated code? Can I debug it? Would that be similar than data behind generated code? I don't know, if I'm honest.
Yeah, debugging is a little tricky right now because it's an alpha and the tools are not yet mature. But yeah, I mean, internally it does generate code, but I don't think you'll ever have to actually work through that generated code. You'll pretty much work with these high-level abstractions. But that being said, yes, debugging is a little bit of a pain right now.
Yeah.
There's a question about Flutter, and I think where that's coming from. Why didn't we cover Flutter here? The reason being, we will primarily focus on native UI frameworks which target the platform natively, and Flutter is more like it ships with its own rendering engine and it draws it on in its own rendering engine instead of targeting the UI toolkit directly. And that's the same with React Native, which is why we didn't cover those. Does it recycle items like recycle? Yes, it does. Again, as I said, right, on surface, it might seem like when you consume a new live data or observable emission for your list, the entire list is being redrawn. That's what it seems like from the code that you see on surface. But internally, that's not the case. It will use diffutils to basically partially update the list.
On that note, there is a composable that's, I can't remember exactly what it's called and I haven't really used it, but it's like a lazy list. So I think the team are working on having something similar to RecycleView where you can recycle components and sort of load them in a lazy fashion. I haven't really used it, but I've seen some people using it, and I think that will be kind of the replacement, so to say, for the RecycleView.
How do you think Declarative UI and Jetpack Compose fit into the future? That's a very good question. I think the more these frameworks converge, the better it is for developers, because if you learn SwiftUI, the core constructs will still remain the same when you look at Compose. So it's only the syntax that would vary. So you can pretty much transfer your mental model and understanding into Jetpack Compose and would be able to pick it up rather quickly. Thanks.
I think the Compose managed the diffing to enable partial updates. I think that was kind of covered by Prateek's section in the talk. There is the subject of what's it called? Something positional memorization. I think in Compose. I think that's probably worth looking into. I think Leyland Richardson, I think that's his surname, from Google, wrote some stuff about that, and so that could be worth looking up on if you want to learn more about that.
Yeah, and I'm not sure how much has changed since the last alpha, but I do remember there being a specific composable, I think called adapter list, if I'm not wrong, that pretty much does what RecycleView will do today. Are there things in the imperative UI that you would miss when going full declarative? Oh man, yeah, we'll miss the bugs.
Yeah, I was going to say no. I think part of it is like it's habit. Like it will take a bit of a shift because I think we're so used to the way we build things at the moment, and I guess you like just knowing how to do certain things and knowing how to do things. I think it will just be missing that natural. Oh, I know how to do this, and that looking things up. I guess that's all part of learning, and that's pretty much what we're paid to do.
Yeah.
So our job.
Yeah, and then on that note, I think if people are starting off mobile development with a declarative framework, they'll find it much easier to adopt it because they don't come with the legacy baggage of doing things the imperative way. It's us who have been doing Android work for a while or iOS for a while that it takes a little longer to just jump ship into the idea. Oh, this is how declarative UI works. So for beginners, it's quite easy actually.
When do you predict Compose? my prediction is summer next year. That's a complete guess, but I have no idea. That could be too early. I don't know. It depends. I think there's a lot of changes happening, and there's probably still a lot of work that needs to be done. But yeah.
How do you think declarative UI fits? Okay, that's the same one.
Yeah. I think that looks like it for questions. I don't think there's any others coming up. Yeah. So
Oh, would you agree with the statement that in less than 3 years, more than 50% of new native Android apps will? I don't know, uh, because that's a metric Google would have to track. But I think it's compelling. Like once you try it out and it makes sense to you, you would much rather be willing to make your UIs using Compose than writing XML.
I just saw a code come up about Compose with Kotlin multi-platform. I think it was a question. There is some stuff. We did see that. What was it? JetBrains are actually hiring people to work on Compose, building composables like Kotlin, like without separated from Android. I think. Prateek sent me a link, so I think there is plans to have it as whether it's like a multi-platform UI components or whether it's abstracted stuff. I didn't really see too much context, but there's definitely something in the works there. So,
how does styling work with Compose? Joe, you can take that.
How does styling work? You need to create custom views, all the good stuff. No, you can do all that stuff in the code. So in Compose, you have the concept of modifiers, which kind of allow you to set things like margins, padding, backgrounds, literally anything you want, like to style stuff, and that would all be done through either modifiers or things like alignment will be done in like the parent containers if you want to achieve that stuff. So I think that I don't think everything's there that is in how we currently do things in the imperative fashion in the Android UI framework, but most of it's there and you can achieve most of the stuff that you could do at the moment. So yeah, that would be the way to go about that.
Would be nice to add Flutter to your. Oh yeah, I mean, again, we decided not to include Flutter and Litho and the whole Yoga layout system because they don't natively target Android or iOS. They're again an abstraction which draw things on their own. So that's the reason we just focus on the native frameworks. How navigation works in Compose. Can we use that? Oh, I think Joe has some interesting points here.
Yeah, I did see a commit in the Compose project where they're working on adding something to the navigation component. It seemed like very early stages. I don't know if that's going to be like final support for it. But so be able to navigate from one composable to another, I think, as like your screen. So that kind of removes the need for fragments, essentially, which I think will make a lot of people happy. So you can have like an activity that just loads your app and then you can navigate between composables using the navigation component. That looks like what the aim is. I have no idea whether that's going to be the final solution or anything. I guess we'll have to see. So I guess that answers the next question about making fragments obsolete. Maybe, I don't know. Like, I don't hate fragments. I think they have their place, but maybe it will. You'll probably have to do a lot of stuff in composables, and fragments might still be around. And who knows? Yeah,
I think it was stressed by the Google team earlier that the current UI toolkit is not going anywhere. They'll still be there. Fragments will still be there. It's now that you have an alternative to fragments to building your UI. So yeah, that's an option that you can do.
Cool. I think that looks like all the questions. So I think we'll leave it there. Out of time as well. So yeah, thanks again for joining our talk. Hope you all have a great day. Enjoy the rest of the conference. There is a panel. Just going to do a shameless plug here. There is a panel later on Jetpack Compose. That Google is going to be asking a bunch of questions. So if you're interested in Compose, please come along to that. And yeah, might be some more good insights. But yeah, thanks for watching and see you all soon.
Thanks everyone. Have a good one.
See you later.